Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have a function and we have to determine if this function is continuous on the entire real line. That's the question. So how do we determine continuity of a function? Now, there are different types of function and we determine the continuity in a different way. This particular function is called a rational function. And the reason being, it's almost like a rational number in real number line, and then we have generalized that concept to function. It's a rational function because it has a numerator and a denominator, and both the top and the bottom, they are polynomials, and that's why it's a rational function. So, when is a rational function continuous, or where is a rational function continuous, for which values? The rational function is continuous on its domain. And domain means whatever x value we can plug in the function without breaking it, you can call. So we have to figure out what is the domain of the function. If we can, we know exactly those are the values where the function is continuous, and then we can answer our question. All right, so let's figure out the domain of this function. So let's take the function. So what is the domain of f? Okay, so look at our function. Is there any x value when you plug in, you will not get a y value? Is there anything like that? Well, if you consider the function one more time, so 3 over x squared minus 16, notice that the numerator wouldn't give us any trouble at all. But look at the denominator. Whenever a function has a denominator, there's always the chance that we can have a 0 in the denominator. And that means the function will not be defined there. So is there any place where the denominator can be 0? Well, there is x squared minus 16, and that can be 0. So let's see if we can rewrite this function a little bit more in a way that we can exactly figure out which values for x will give us a 0 in the denominator. Now notice x squared minus 16 is a difference of two squares. It is like a squared minus b squared, that form. And if we have anything of this form, difference of two squares, a squared minus b squared, then we can factor them. And the factors are a minus b and a plus b. Okay? So we have x squared, and 16 is 4 squared. So here is our a, and here is our b. This is a, and this is b. So let's factor it. A minus b, so x minus 4, and a plus b, x plus 4. Now as soon as we have linear factors, we know exactly when they are 0. Okay, so we know that x minus 4 is 0 if x is 4, and x plus 4 is 0 if x is negative 4. So definitely those 2 points cannot be in the domain of the function. So we can conclude that domain of f is all real numbers except those 2 points. And in the interval notation, that means it is all the numbers from negative infinity to negative 4 and from 4 to infinity and everything in between. So between negative 4 and 4. So all the real numbers except those 2 values. And remember what I said, a rational function is continuous on its domain. So we can conclude, therefore, the function is not continuous on the entire real line. It is only continuous on these intervals. So f is continuous on negative infinity, negative 4, negative 4 to 4, and 4 to infinity. And so the answer is no. F is not continuous on the entire real line. Thank you.